Gentlemen. Okay, ladies and gentlemen, welcome back. Now, just a reminder, critical numbers where the derivative equals 0 or does not exist. Intervals of increase and decrease. Increasing is where the first derivative is positive, decreasing where the first derivative is negative. Local maximum, minimum, that's critical values where the sign of the derivative changes. Now, once again, all well and good. But this leads up to the first derivative test for absolute extrema. So, notice it's absolute extrema. That's it. It's the highest point or it's the lowest point. Now, for this, once again, f is continuous. And c is a critical number. Now here, first thing to note, if f prime of x is positive, for all x less than c, and f prime of x is negative, for all x greater than c, then f of c is the, not an, is the, it's the only. So, if f prime of x is positive for all x less than c, and f prime of x is negative for all x greater than c, then f of c is the absolute maximum. Now conversely, if f prime of x is negative, and prime of x is positive, then f of c is the absolute minimum. Okay, so once you got that, so let's find absolute maximum minimum values for f of x equals 3 minus 1 over the square root of x squared plus 1. So, note here, if you want to, you could really write this minus x squared plus 1 to the minus 1/2. If you want to write it that way, I'm okay. Doesn't really matter. So, what's the derivative? Okay, minus 1/2 x squared plus 1 minus 3/2 times the derivative of x squared, 2 x squared, which is 2x. Minus minus becomes a plus 1/2. 2 cancels out, so this becomes x over x squared plus 1 to the 3/2. We usually write it like that. Double check and make certain I got it right. Now, first things first, is this bloody thing continuous? That is, as long as x squared plus 1 to the minus 3/2 doesn't equal 0. So x squared plus 1 can't equal 0. X squared cannot equal minus 1. So yes, it's continuous because you can't take the square root of negative 1. Since we can't take the square root of negative 1, it's continuous, which is good. Makes life a little simpler. Now, that means we've got to find where the derivative equals 0. So f prime Now, can you imagine doing this without a calculator? Woohoo! All right, now, when does this equal 0? Well, I don't know. Well, I do, because I figured it out. What do you do where you solve for x? So you multiply both sides by x squared plus 1 to the 3 halves. So you get x equals 0. So you have one critical value when x equals 0. So all of a sudden, this big, evil, ugly equation is pretty straightforward. 0. So now we find the derivative. I'm going to say minus 1. I get minus 1 over the root of 8, or a negative number. So plug in the numbers, or just look at your table of values. Honestly, it's just easier with the table of values. Okay, so it goes from a negative to a positive, which makes this the absolute minimum. Now the last question is, what's the coordinates of the absolute minimum? Well, in that case, it's f of 0, not f prime, the original function. F of 0 is what? 3 minus 1 over square root of x squared plus 1. If it's 0, it's 3 minus 1 over 1. Technically, square root of 1. 3 minus 1, which is 2, I think. So the coordinates of the absolute minimum are 0, 2. Now, if you grab your graphing calculator, you can check all that. Honestly, you can do your graphing calculator and make certain you do the correct answer, get a correct answer. But anyway. So, homework, page 182, numbers 1 to 6. Work on those, please. And good luck.